Imagine you are standing on Earth, 66 million years ago. The air is warm, the ground beneath your feet is alive with movement. Towering trees stretch toward the sky, insects buzz, birds call from the canopy. Somewhere nearby, massive dinosaurs move slowly through the forest, unaware, unafraid, unchallenged. This world has existed like this for millions of years. It feels permanent, unbreakable. Nothing suggests that today is different. The sun rises as it always has. Rivers flow, oceans breathe. Life continues its ancient rhythm. The dinosaurs are not dying, they are not weak, they are at the peak of their dominance as kings of land, sea, and sky. And yet, something is already coming. Far beyond the blue sky, past the clouds, past the atmosphere, a mountain-sized rock is racing toward Earth. It has been traveling through space for millions of years, silent, unnoticed, unstoppable. No animal senses it. No instinct warns them. Evolution has prepared life for predators, hunger, disease, but not for the sky itself to fall. Then it appears. A sudden, blinding point of light streaks across the heavens, brighter than the sun, faster than sound. For a brief moment, the sky looks like it's tearing open. Animals pause. Some look up. They have no idea what they're seeing. The fireball grows larger with every second, dragging a tail of flame across the atmosphere. The air begins to heat. The horizon glows. The planet itself seems to hold its breath. There is no escape, no warning, no survival plan. In a matter of moments, this single object, no larger than a city, will unleash more energy than every nuclear weapon humans will ever build. Oceans will rise, continents will shake, the age of giants will end. The dinosaurs don't know it yet, but their world is already over, because in the next 10 minutes, Earth will change forever. The asteroid. The object that ended the age of dinosaurs was not just a random space rock, it was a true planetary killer. This asteroid was roughly 10 to 12 kilometers wide. To understand that size, imagine Mount Everest laid on its side, or a city stretching from one end to the other. This was not something that burned up in the atmosphere. This was something Earth could not ignore. Scientists estimate its size using the crater it left behind, now buried beneath the Yucatan Peninsula in Mexico, known as the Chicxulub crater. The asteroid was moving at an unimaginable speed, around 20 kilometers per second. That is more than 70,000 kilometers per hour, faster than a rifle bullet, faster than sound. At that speed, the moment it hit Earth, there was no such thing as slowing down. The impact happened almost instantly, releasing all its energy in a fraction of a second. When it struck, it punched a crater nearly 180 kilometers wide and about 20 kilometers deep. The ground beneath Mexico did not just crack, it vaporized. Rock behaved like liquid. Entire layers of Earth's crust were blown outward, thrown into the atmosphere, and even into space. The Chicxulub crater is still one of the largest confirmed impact structures on Earth. The energy released by this impact is almost impossible to comprehend. Scientists estimate it was equivalent to more than 100 trillion tons of TNT. That is, billions of times more powerful than the atomic bomb dropped on Hiroshima. In a single moment, more energy was released than all volcanic eruptions in human history combined. But here's the terrifying part. This was not just an explosion at one location. The Earth itself absorbed the shock. Seismic waves raced through the planet. The atmosphere ignited. The oceans reacted. This was not a local disaster. This was a global event. Asteroids have hit Earth before. Many have hit since. But this one struck at the worst possible place, at the worst possible angle, into sulfur-rich rocks that turned an impact into a planet-wide catastrophe. This was not just another asteroid. This was the one that ended an era. The first minutes after impact. The moment the asteroid struck Earth, the planet responded like a living thing in pain. The impact triggered earthquakes far beyond anything humans have ever recorded. Scientists estimate the equivalent of magnitude 10 or even higher, strong enough to send seismic waves racing through the entire planet. The ground didn't just shake near the impact site, it rippled across continents. Mountains trembled, fault lines shifted. In some places, the surface of the Earth briefly behaved like liquid. A colossal shockwave exploded outward from the impact point. It tore through the atmosphere faster than the speed of sound, circling the globe multiple times. Anything standing within thousands of kilometers was flattened. Trees snapped like matchsticks. Animals were thrown through the air. The pressure alone was enough to rupture lungs and shatter bones. Within minutes, the oceans responded. The asteroid struck shallow seas, instantly displacing unimaginable volumes of water. Mega tsunamis, hundreds of meters high, surged outward in all directions. These were not waves that crashed and retreated. They tore entire coastlines apart, scouring the land, dragging marine life far inland, and erasing ecosystems that had existed for millions of years. Geological evidence of these tsunamis has been found as far away as the Caribbean and North America, but the most terrifying part came from above. The impact blasted trillions of tons of molten rock and debris into the sky. For a brief moment, pieces of Earth itself reached space. Then, gravity pulled them back. As this debris re-entered the atmosphere, it superheated the air across the globe. The sky itself became an oven. Temperatures spiked so suddenly that vegetation ignited almost everywhere at once. Forests didn't burn slowly, they flashed into flame. Charcoal layers found all over the world tell the same story. From North America to Europe to Asia, wildfires erupted nearly simultaneously. Animals that survived the initial blast now faced walls of fire with no escape. Even regions far from the impact zone were engulfed. In less than an hour, Earth was unrecognizable. The ground was still shaking, the oceans were still rising, fire raged across continents, smoke and ash climbed into the sky, beginning a chain reaction that would darken the planet for years. The asteroid was gone, but the real extinction had only just begun. Firestorms in global hell. What followed the impact was not a single disaster, but a planet-wide chain reaction. As trillions of tons of rock were blasted into space, Earth briefly looked like it was shedding its own skin. But gravity always wins. Within minutes to hours, this debris began to fall back through the atmosphere. Each fragment re-entered at extreme speed, heating the air around it until the entire sky glowed. The atmosphere itself became a source of heat, raising surface temperatures across the globe. This heat pulse did not behave like a normal wildfire. It arrived almost everywhere at once. Scientists believe temperatures rose high enough to ignite dry vegetation instantly, even thousands of kilometers away from the impact site. Forests, grasslands, and coastal regions erupted into flames within minutes. There was no advancing fire line. There was no place to run. The evidence of this global inferno is written into the rocks themselves. Thin layers of charcoal have been found in sediments dating precisely to the extinction boundary on multiple continents. These layers show that fires were not local or regional. They were worldwide. Earth, for a brief period, was burning on a planetary scale. Animals did not need to be near the impact to die. Many were killed by the sudden heat alone. Others suffocated as smoke and ash choked the air. In some regions, oxygen levels dropped while toxic gases rose. Even large, powerful dinosaurs could not survive in an environment that turned breathable air into poison. Night did not bring relief. Flames reflected off smoke-filled skies, turning darkness into an orange glow. The ground remained hot. Ash rained down continuously. Rivers filled with debris. The world entered a state of chaos that no ecosystem had ever experienced before. And when the fires finally began to fade, nothing living recognized the planet beneath them. The forests were gone. The air was dark. The sun was dimming. The asteroid had delivered the first blow. Fire had delivered the second. But fire was only the beginning. When the sun disappeared. After the fires burned and the ground finally stopped shaking, Earth entered a far deadlier phase, one that didn't explode or roar, one that crept in silently. The asteroid impact blasted enormous quantities of dust, soot, and sulfur-rich material high into the atmosphere, not just into the clouds, but into the stratosphere, where rain could not wash it away. This dark veil spread rapidly around the planet, blocking sunlight on a global scale. Imagine waking up one day and the sun never truly rises again. Climate models and geological evidence suggest that daylight dropped to a fraction of normal levels. In many places, the sky would have looked like permanent twilight. Some regions may have experienced near total darkness for months, possibly even years. What happens to life when sunlight disappears? Photosynthesis collapsed almost immediately. Plants on land began to die within weeks. In the oceans, microscopic plankton, the foundation of marine food webs, vanished in staggering numbers. Without sunlight, the engines that powered life on Earth simply shut down. As the darkness spread, temperatures plummeted. Earth experienced a sudden and extreme global cooling event, often called an impact winter. Average temperatures may have dropped by more than 20 degrees Celsius in a matter of months. Tropical regions turned cold, seasonal patterns collapsed. Animals adapted to warm climates now faced freezing conditions they had never evolved to survive. But cold was not the only threat falling from the sky. The asteroid struck sulfur-rich rocks, launching massive amounts of sulfur dioxide into the atmosphere. When combined with water vapor, this formed sulfuric acid, which returned to the surface as acid rain. Rain that burned leaves, poisoned fresh water, and further weakened already collapsing ecosystems. The planet grew quiet. No birdsong, no insect hum. Forests stood dead and blackened, stripped of leaves. Rivers carried ash instead of life. Oceans became hostile, acidic, and starved of energy. How long can large animals survive without food? For most dinosaurs, the answer was not long. Herbivores starved as plants vanished. Carnivores followed soon after. Even survivors of the fires and earthquakes now faced an invisible enemy they could not outrun or fight. The asteroid itself had been gone for a long time, but its shadow still covered the Earth. And under that shadow, the greatest mass extinction since the age of complex life continued its slow, merciless work. Collapse of life on land. When the sun disappeared and plants began to die, the fate of the dinosaurs was sealed. Plants are not just scenery, they are the foundation of life on land. Within weeks of the impact of winter, forests stopped growing, leaves fell and never returned, seeds failed to sprout. Fossil pollen records show a sudden and dramatic decline in plant diversity exactly at the extinction boundary. Herbivorous dinosaurs were the first giants to fall. Massive creatures like Triceratops and Hadrosaurs required enormous amounts of food every single day. When plants vanished, their energy reserves disappeared with them. There was no alternative diet, no stored food. Starvation set in rapidly, not over centuries, but over months. Bone beds from the end of the Cretaceous show signs of stress and sudden population collapse rather than slow decline. Carnivores survived only slightly longer. Predators, like Tyrannosaurus rex, depended entirely on herbivores for survival. As prey populations collapsed, carnivores faced the same fate. Large predators require constant calories. Once food became scarce, their size became a fatal disadvantage. A body built for dominance now demanded energy the environment could no longer provide. Size, which had once made dinosaurs unstoppable, now worked against them. Large animals reproduce slowly. They need vast territories. They cannot hide. They cannot burrow. Small mammals, reptiles, and birds could shelter underground, slow their metabolism, or survive on insects and debris. Dinosaurs, built for a lush world, were trapped in a dead one. The fossil record tells a brutal story. Across the globe, dinosaur fossils abruptly disappear above the same thin clay layer, rich in iridium, a metal associated with asteroid impacts. There is no gradual fade, no long decline, just a sharp ending, a biological cliff. The greatest animals to ever walk the earth did not go down in battle. They starved, they weakened, they vanished from a world that no longer had a place for giants, and with their disappearance, Earth entered a strange and empty chapter where survival no longer belonged to the biggest or the strongest, but to the smallest and the most adaptable. Oceans in crisis. While life on land was collapsing, the oceans were facing their own silent catastrophe. The seas may seem vast and resilient, but they depend on something fragile: sunlight. When the asteroid's dust and soot darkened the sky, sunlight stopped penetrating the upper layers of the ocean. Photosynthetic plankton, the microscopic organisms that form the base of nearly all marine food chains, began to die in massive numbers. This collapse happened fast. Marine sediments from the extinction boundary show a sudden disappearance of many plankton species, including foraminifera and coccolithophores. These organisms had survived for tens of millions of years, only to vanish almost instantly in geological terms. Without plankton, the oceans lost their primary energy source. The effects rippled upward. Creatures that fed on plankton starved. Fish populations declined. Larger marine predators followed. One of the most dramatic losses was the ammonites, spiral-shelled relatives of modern squid. Ammonites had thrived for over 300 million years, surviving multiple mass extinctions. They did not survive this one. At the same time, the chemistry of the oceans was changing. Sulfur dioxide and carbon dioxide released by the impact dissolved into seawater, increasing acidity. This ocean acidification made it difficult for organisms with shells or skeletons made of calcium carbonate to survive. Shells dissolved. Reproduction failed. Entire groups disappeared from the fossil record. The oceans did not burn like the forests. They starved. Food webs that had taken millions of years to build unraveled in a matter of months. Ecosystems simplified. Complex marine communities collapsed into sparse, microbial-dominated systems. From the surface to the seafloor, life retreated. The extinction that followed the asteroid was not selective. It did not care whether life lived on land or in the sea. It struck the foundation of both. And as the oceans emptied of familiar life, Earth became a quieter, simpler, and far more dangerous place to exist. Who made it through? Amid the ashes, darkness, and starvation, life did not disappear entirely. Some creatures endured, some adapted, some survived the unthinkable. The key was not strength. The dinosaurs had strength in abundance, but it did not save them. Survival had nothing to do with size or power, and everything to do with adaptability. Small bodies, versatile habits, and the ability to hide became the greatest advantages in a world turned hostile. Burrowing mammals are among the most famous survivors. Tiny, rodent-like creatures could retreat underground, where temperatures were slightly more stable and darkness less complete. They fed on roots, seeds, insects, and detritus, whatever they could scavenge. Their small size meant lower energy requirements, allowing them to survive months or even years when food above ground disappeared. Crocodiles and turtles also endured. These cold-blooded reptiles could survive on far less food than large mammals or dinosaurs. They could slow their metabolism, remain in water for extended periods, and consume whatever was available, from carrion to small fish. Their aquatic habitats offered protection from the worst of the fires and heat pulses. Birds, the only living descendants of dinosaurs, survived as well. Small, feathered, often flying or climbing species could escape immediate dangers and exploit hidden niches. Many had omnivorous diets, eating seeds, insects, and other small prey. Flexibility in feeding habits, mobility, and reproduction gave them a crucial edge. Even some amphibians persisted. Burrowing, semi-aquatic, or nocturnal species could avoid extreme heat, fire, and sunlight deprivation. Their ability to tolerate changing water chemistry or rely on detritus made them more resilient than larger, specialized species. The common thread among survivors was clear: flexibility, shelter, small size. They were not the rulers of the world before the asteroid, but after they became the architects of its recovery. Life itself had not ended. It had shifted into a form that could endure the unimaginable. As Earth lay in ruin, these survivors would form the seeds of a new age. Mammals would diversify, birds would take to the skies, turtles and crocodiles would continue their ancient lineages. The giants were gone, but life itself refused to surrender. Survival had nothing to do with strength. Everything depended on adaptability. Earth's reset button. After the fires burned out and the skies began to clear, Earth looked unrecognizable. Forests that had stood for millions of years were gone. Trees, ferns, and flowering plants that once filled every landscape had vanished under ash, heat, and darkness. In their place, a single type of plant rose almost everywhere: ferns. This sudden dominance is recorded in what scientists call the fern spike. Pollen fossils from the time immediately after the asteroid impact show an overwhelming increase in fern spores, often making up the majority of plant pollen in sediment layers worldwide. These hardy plants were among the few capable of quickly recolonizing devastated land. Ferns thrived because they could grow in poor soils, reproduce rapidly, and survive in environments where other plants could not. They did not need sunlight as much as flowering trees, and their simple life cycle allowed them to repopulate scorched landscapes quickly. For a time, the world became a green sea of ferns, covering plains, riverbanks, and volcanic soils. This dominance of ferns also reflects the larger collapse of ecosystems. Large, complex forests gave way to open, simplified environments. Animals that had relied on dense forests for food and shelter found themselves in a stark, unfamiliar world. The fern spike marks a planetary reset, a pause in the complexity of life while survivors regrouped. For thousands of years, this fern-dominated world served as the first stage of recovery. It was a quiet, fragile landscape, signaling both the devastation of the past and the slow return of life. Ferns were not just plants, they were nature's first responders, reclaiming the planet and creating the foundation for the new ecosystems that would eventually emerge. The Earth had reset itself. From the ashes of destruction, the simplest survivors paved the way for everything that would follow. The long recovery. The asteroid did not just end the age of dinosaurs, it reshaped life on Earth for millions of years. Recovery was neither quick nor simple. Contrary to what movies or cartoons might suggest, the planet did not bounce back in a few decades. Ecosystems rebuilt themselves slowly, piece by piece, over millions of years. The first stage of recovery saw ferns and other hardy plants dominate, but forests did not return immediately. It took hundreds of thousands of years for trees and flowering plants to recolonize the land and rebuild complex habitats. Soil needed to regenerate, and animals had to adapt to radically altered environments. Meanwhile, mammals began to take advantage of the empty niches left by the extinction of dinosaurs. Small, rodent-like creatures diversified rapidly, evolving into a variety of forms capable of occupying different environments. Over millions of years, mammals grew larger, became more specialized, and eventually dominated the land in ways they never could have, while dinosaurs reigned. Birds, descendants of avian dinosaurs, also flourished. Freed from predation and competition by large terrestrial dinosaurs, they evolved into new species and spread across continents. Their diversification set the stage for the familiar bird lineages we see today. In the oceans, food webs slowly regained complexity. Plankton recovered, allowing fish and marine reptiles to re-establish populations. Coral reefs re-emerged in some areas, creating habitats for diverse marine life. Life, though still fragile, began reclaiming the planet. The world we recognize today, the forests, oceans, and creatures that populate them, did not appear overnight. It took millions of years for ecosystems to regain their complexity. Species evolved, adapted, and filled niches in a slow, patient process dictated by survival, mutation, and chance. The Cretaceous-Paleogene extinction did not mark the end of life. It was a reset button, a dramatic pivot that allowed new forms of life to rise. The world you know today took millions of years to heal, and that slow recovery shaped the evolution of mammals, birds, and eventually humanity itself. Why this event matters today. The extinction that wiped out the dinosaurs was not just a chapter in a distant past. It is a story that directly shaped the world we live in today. Had the asteroid never struck, mammals might never have risen to prominence. Humans might never have existed. The very fact that we are here is a consequence of this cataclysm.